Hi students, welcome to Alpha's e-learning program Mathematics session 80. Now we are going to discuss problems on different forms of parabola. Let us observe here some problems. In previous sessions we have observed how to get here equations of different forms in parabola values. Now observe here, focus is given, vertex is given. Then they are asking about equation of parabola. Okay, so focus given, vertex given. Now as we have done concept basing on actually where axis is exactly parallel to x-axis or along x-axis, similarly y-axis also. That's why here students observe, whenever a problem is given, this is here focus 3, 1 given, vertex 3, -2 given. And we know again here focus and vertex both they lie on axis of parabola. Okay, axis of parabola. Then observe here, before you start any method, just observe here how are the given points. In these points abscissa is same. Okay, when abscissa is same, then what about here that particular line? Okay, abscissa is coming same here, that means here 3, 1 and the other point is 3, -2. That means if this is 3, 1, then this value is here 3, -2. That means here moreover you know focus vertex they lie on axis of parabola. That means here this is actually axis of parabola and this axis of parabola is exactly how it is parallel to y-axis. Now whenever axis of parabola is parallel to y-axis, then what about our standard form? The standard form is of the form x minus alpha whole square is equal to 4a times y minus beta, or it can be here minus 4a also. That means this is actually here plus or minus 4a into y minus beta when axis is exactly here parallel to y-axis, because this is 3, 1 we got and this is 3, -2. Now what is actually vertex? This is our vertex capital A, right? And vertex is capital A, therefore the parabola has to be here in this way. That means the parabola has to come like this. Understand? Therefore we can observe the parabola is clearly like this, because in previous session already we have observed some properties of here parabola, that is focus is always inside the curve. Therefore this is the focus inside the curve and vertex is 3, -2 implies now the curve is exactly upwards. Whenever it is coming upwards, then here in plus or minus 4a we consider exactly positive value, that is 4a, and vertex this is alpha and this is our beta. Therefore we can write the equation as x minus 3 whole square alpha and equal to plus 4a you got, because it is upwards. Therefore it is 4a into y minus of minus, it is 2. Okay, and next one is what about here this distance 4a. Okay, and while doing the standard form in previous session we have observed, when this is the parabola and this is the tangent at vertex here, if it is focus s of a, 0 and this is vertex 0, 0 and this one is the directrix, that is here minus a, 0, then what is our observation? SA equal to AZ equal to small a. Understand? So this is our small a, and 4 times distance between focus and vertex is nothing but our 4a value. Okay, now here you are having already these values, that means focus and vertex already we have in hand. Therefore what about here distance between them? It is exactly how many units here? It is 3 units. Okay, 1 plus 2 whole square, if you take root of, then it is 3 units. So you got a value as 3, thereby 4a is how much here? 12. Therefore completely the equation is nothing but here this is equal to x minus 3 whole square. Okay, x minus 3 whole square equal to 4 into that a is nothing but here as, and as value is nothing but how much here? It is 3. Therefore this is 3 into y plus 2. Okay, therefore we know here as is equal to small a. And now here if you simplify this, that is our standard equation of parabola. Okay, so this is the method when focus is given and vertex is given. Now observe again this problem. Here also you can observe 1, -7, vertex is given as 1, -2. Okay, So focus given as 1 comma minus 7 and vertex given as 1 minus 2. Then how we can arrange them? We can arrange them actually here. Just again, abscissa is same here, x coordinate is same, and whenever x coordinate is same here, the axis of parabola is exactly just now whatever we have done, it is exactly parallel to y axis. So one point you got here, this is 1 comma minus 2 and the other value is 1 comma minus 7. Okay, now this is given as actually vertex and this value is here focus. Therefore, how is our parabola? Because this is the vertex and this is focus. Now the parabola is of this model. Okay, that means the vertex is here parallel to which one? Y-axis. It is parallel to y-axis. Vertex you know, but how is the curve? It is falling exactly downwards. Whenever it is downwards, what is our formula? X minus alpha whole square equal to minus 4a times it is y minus beta. Okay, minus 4a times y minus beta, and this is our alpha and beta. So x minus 1 whole square equal to minus 4a into y plus 2, right? Now after you got this value, again just like the previous problem, AS is nothing but how much here? It is 2 units. Okay, as AS is here, sorry, AS equal to A units. As AS is A units, then we apply again distance formula. Thereby the distance between AS is nothing but here 5 units. And therefore we write this value as x minus 1 whole square equal to minus 4 into this is 5 units, that is minus 20 times it is y plus 2. Okay, so if you simplify, that is our equation of parabola. Therefore whenever in any data focus is given, vertex is given, we are doing problems basing on where either abscissa is same, sometimes ordinate also may be same. Okay, abscissa same or ordinate same, simply we can make use of here standard form problems. Sometimes problems are there where focus is 1 minus 7, vertex is some other value, that is 3 comma 4. That concept we will discuss at the time of oblique parabola, when axis is not parallel to either of coordinate axis. Okay. Now let us observe students the other model, that is find equation of parabola whose axis is parallel to y-axis and passing through here 3 points. Okay, what is the method of this problem? The method is nothing but here, if you come across with this model, a parabola is passing through 3 points and axis is parallel to, implies simply we have one more standard form, that is whenever it is parallel to y-axis, then we write it as y equal to how much? It is Lx square plus mx plus n. Okay, so this is the standard equation when the axis is here parallel to y-axis. Suppose the axis is parallel to x-axis, then we write as x equal to Ly square plus my plus n. Okay, now what are our unknowns in the problem? The unknowns are L, M, n. Therefore here 3 unknowns are there, that's why they gave here 3 conditions, that is here points. Okay, now let us take this equation as here 1. Now let us substitute here those points, because this parabola is passing through those 3 points. First I am taking here 2 comma 5 point, and thereby this is our y, so 5 equal to here 4L plus 2M plus n. Okay, this is equation 2. And next I am taking the point, the other one is 1 comma 4. Okay, 1 comma 4. Then 4 is equal to here L plus M plus n. This is our equation 3. And next point is minus 1 comma 8. If I take minus 1 comma 8, then this is 8 equal to, okay, then this is L, and next minus M, and this value is n. So here you got 3 equations in 3 variables. Now while doing this calculation, students, always better you observe, every time you are going to get here plus n itself. Okay, plus n. That's why better first eliminate n, thereby the simplification part will be very easy. So how to eliminate n value here? 2 minus 3 I am taking. So 2 minus 3, 5, right? Then what is that equation? It is 1 equal to, this is 3L and plus M, okay? 2 minus 3. Then you can use 3 minus 4 or you can use 4 minus 2. Anyways you can use. Suppose I am taking 3 minus 4. So 3 minus 4 implies, what is this value? 4 minus 8. Minus 4 is equal to, and this side here we are subtracting, therefore here minus n, this cancel as well as L also cancelled. So how much you got here? 2m, okay? We subtracted here 3 and then here 4. That means 3 minus 4. So 4 minus 8 minus 4. L and L get cancelled. M plus M, 2m, and this also cancelled. So finally you got here m is equal to how much? Minus 2. And that m is minus 2, you substitute here. Then what will happen if I substitute here, this m is minus 2, then this is nothing but 1 is equal to 3L minus 2. That implies 3L is 3, implies L is 1. So once you got one value, then automatically the other values also we are going to get. Now m is minus 2 already we got, L equal to 1 we got, and these two values you substitute in any of these three values, that is 2, 3, 4, we can obtain n value also. So if I take here from equation, it is 3, or you can put in 4, okay? So from equation 3, if I write here, this is nothing but how much here? 4 is equal to, third equation, L value, it is 1, okay? M value minus 2 plus n, okay? That implies 4 is minus 1 plus n, and hence n equal to how much here? 5. Finally you got here all the values Lm, n. Then here if you substitute y equal to, the equation of parabola is y equal to now Lx square, L is 1, so x square, and next m value minus 2, that is minus 2x, and next value n is how much here? 5. So this is our equation of parabola, okay? So whenever any time a problem is given, find equation of parabola whose axis is parallel to y-axis, then we start it as y equal to, and three unknown values here, actually Lmn, that's why they gave here three conditions as 3 points, okay? Then we substituted each of the point here, thereby we obtained here Lmn values, and finally we substituted in equation 1, this is our equation of parabola. If at all you have any doubt, just check here 2, 5 you substitute here, you must get equation as balance. 5 equal to here it is 4, and 4 plus 5 9, 9 minus it is 4, that is again 5, 5 equal to 5. Like that also you can check verify, okay? And in the same way students, the other problem that is given as find equation of parabola parallel to x-axis. Okay, now in these model problems, if at all, if they do not ask equation of parabola, instead of that they may ask here what about length of lattice rectum. Okay, now length of lattice rectum to this standard form, in previous session we have observed it is nothing but 1 divided by mod L. Okay, so 1 by mod L means in this problem what is the value students? It is 1 only. Okay, so like this here also they may ask here find length of lattice rectum of parabola whose axis is parallel to x-axis and passing through the 3 points. Okay, so again you find here, once you got coefficient of x square, directly you can take here the reciprocal of the positive here, that is 1 divided by mod L, that is our length of lattice rectum in this kind of standard form. Okay, now this one, that is find equation of parabola whose axis is here parallel to x-axis given. So parallel to x-axis means you have to take the problem as here x equal to, okay, x is equal to Ly square plus my plus n, and then again just like the previous problem substitute here each of the points, that means minus 2, 1 etc. each of the points you substitute. Suppose if it is minus 2, 1, if I substituted, then what is this value here? You are substituting for x. Okay, so minus 2 equal to it is L plus m plus n. So this is our equation 1, and now this is our equation 2, and next you are going to substitute 1, 2. So here x is 1, 1 is equal to, here you will get 4L and plus 2M plus N. Okay, this is equation 3. And next we substitute minus 1 comma 3. Okay, if I substitute this point, then what is the value here? Minus 1 is equal to here 9L and plus this is 3M plus N. Now just like the previous problem, if you solve these three equations, you can obtain here element values. That means what we do here? 2 minus 3. Okay, 2 minus 3 will take, and next we'll take 3 minus 4, or you can take 4 minus 2 also. Then if I write 2 minus 3 here, then what is the equation? 2 minus 3 implies it is minus 3 equal to, okay, and here this is minus 3L and this value is minus M, right? That implies you can write it as even 3 equal to 3L plus M. So this is one equation you got, and the other one you can take here 3 minus 4, or you can take 4 minus 2 also. Suppose if I write 3 minus 4, then what is this value here? 1 plus 1, okay, that is 2 equal to 4 minus 9 minus 5L, and this is minus M. Okay, now let us again solve these two equations. If these two are 5 and 6, okay, in previous problem while taking this directly you got here one of the values M you got, whereas here both the equations are in terms of L and M. Now I am adding directly because here plus M minus M is there. Therefore it is 5 equal to how much? Minus 2L. Okay students, that implies L equal to how much here you got? Minus 5 divided by 2. Okay. Now in this problem, if at all they asked you about lattice rectum length, then it is nothing but 1 by mod L. That implies it's nothing but 2 divided by 5. Okay. So now next again you have to substitute this L value in one of these, thereby you can obtain M value. Similarly you can get N value also. Okay students, so this is the method to solve here whenever they asked about equation of parabola whose axis is parallel to x-axis. We have to start with x is equal to. Okay, so in this way we can conclude this problem, right? Now students, observe this problem here. End points of lattice rectum given. Okay, end points of lattice rectum given minus 3 comma 2 and minus 3 comma 1. Here which value is the same actually? Minus 3 minus 3. These are end points of lattice rectum. Okay, so now here how is here the value? Abscissa is the same. Understand? Abscissa is the same. When abscissa is the same, then how is that line? It is parallel to y-axis. Okay, so the line is here parallel to y-axis. Now one point you got, it is minus 3 comma 2, and the other point we got minus 3 comma 1. Okay, so these are the 2 points which are ends of lattice rectum. And whenever lattice rectum, if you observe students, it is always perpendicular to axis of parabola. That means here once this is the lattice rectum whose line is parallel to y-axis, then what about axis here? Axis is exactly parallel to x-axis. Okay, so axis is parallel to x-axis and lattice rectum is here exactly perpendicular to x-axis, because here ordinates abscissa is same. Okay, now if I take this is the point L, then this is L dash. Now they are asking about here what is equation of parabola passing through these 2 points. While discussing concept in previous session, we have observed through ends of lattice rectum there exist 2 types of parabolas. Okay, so this is one parabola and this one is another parabola. So for these two actually L and L dash are what here? Lattice rectum ends. Okay, that means there exist always two parabolas which can pass through ends of lattice rectum. Now here these are ends of lattice rectum. So how is the equation? What is the standard form? The standard form is of the form exactly y minus beta whole square. Okay, y minus beta whole square equal to plus or minus 4a, because it may be this model or it may be this model. Okay, it may be any of these models, either this model or this model. That's why we are taking plus or minus 4a into how much it is? X minus alpha. Okay, now what is our requirement here? We don't know about 4a, but 4a is nothing but what here? The distance between these L and L dash, that is length of lattice rectum is nothing but L dash. Therefore, you can get here easily 4a value. Then what about the next requirement here? Alpha and beta. Okay, these two values we need to find. And moreover, the middle point is here minus 3 comma, suppose you got 3 by 2, then directly that value we can't say a value. Understand? Because here whenever the standard form is exactly like this, that means axis is exactly x-axis, then here this point you can take as a comma 0 when these are ends of here lattice rectum. Now what is the case here? The axis is not exactly x-axis. Whatever the axis you got here, that axis is exactly here parallel to x-axis. That's why I cannot take directly this value as a comma 0 and hence here 0 comma 0. In that way we are not supposed to take. So that what to do here? Unknown values are here alpha beta, whereas lengthwise you can treat as same value. So what is LL dash, students, here? That LL dash is here 1 unit. Okay, that means 4a is here exactly 1, because if you use a distance formula, now you can get here 1. Then what about here this value now? Y minus beta whole square is equal to, understand, this is 1 plus or minus x minus alpha. Okay, now what about here alpha and beta? That is our requirement. Then how to solve those alpha beta values? So this is the nature here, the parabola. One point is here minus 3 comma 2 and the other point is here minus 3 comma 1. But how are these 2 points? They are lying on parabola. Understand? This point is on parabola as well as this also. So as point is on the parabola, it has to satisfy the equation. So let us substitute. Y is here how much? Once I am substituting this point, then it is 2 minus beta whole square. Okay, this is equal to plus or minus x minus alpha, that is x plus 3. Suppose it is 1, right? And next value, x means here it is how much actually? This value we are substituting for x and y. Okay, so here this is nothing but how much? Minus 3 minus alpha. Okay, for x we are substituting. And next I am substituting here minus 3 comma 1. So this is here 1 minus beta whole square is equal to plus or minus, what about this value now? It is x we are substituting, that is here minus 3 minus alpha. Okay, now these two are actually one and the same, RHS, because of the nature of the same abscissa. Therefore these two values let us equate. If I equate them, 2 minus beta whole square is equal to, what is the other value? 1 minus beta whole square. Now if I take as it is, square root if I remove, square value if I remove, you will get 2 minus beta is 1 minus beta. We will get 2 is 1, which is absurd. Therefore what should happen here? We can't take plus as it is. I am taking 2 minus beta is minus of here 1 minus beta. In plus or minus, minus value we are taking. That implies 2 minus beta is nothing but here minus 1 plus beta. Therefore you got here 3 equal to 2 beta. Thereby beta is how much now? 3 by 2. Okay students, so you got beta value finally 3 by 2. Once you got beta value as 3 by 2, now we can substitute in 1 or 2. Any values you can substitute to obtain alpha value. Okay, therefore if I take from equation 1, so from equation 1 I am substituting beta value how much here? It is 3 by 2. Okay, so if I write here 2 minus 3 by 2 whole square, okay, and this side it is equal to plus or minus 3 minus alpha. Okay students, we substituted in equation 1 the value of beta as 3 by 2. Now what is this value? 4 minus 3, it is 1 by 2, 1 by 2 whole square, so 1 by 4. This 1 by 4, one time I am taking plus symbol, so minus 3 minus alpha, and next I am taking here minus symbol, that is 3 plus alpha. Okay, now what about here alpha? This alpha, if I write this side, minus 3 minus 1 by 4. So this is minus 13 by 4. And this side, if I take this alpha, 3 this side you send, 1 by 4 minus 3 equal to alpha. So minus 11 by 4 equal to here alpha. Finally, beta value is unique. Okay, beta is unique, that is 3 by 2, whereas alpha you got here minus 13 by 4 and here it is minus 11 by 4. So what about here students, the equation now? We are going to substitute here. This is nothing but y minus beta, that is y minus 3 by 2 whole square. Okay, and this is equal to plus or minus x minus alpha. One time I am substituting this, that is x minus of minus plus 13 by 4. Okay, and next value, what is the other value you can substitute here? The other value you are substituting as here minus 11 by 4. Okay, now in these cases actually which value we have taken while simplifying? Minus value, isn't it? While simplifying minus value we have taken, therefore we need to substitute here x plus 13 by 4, and the other case actually it is minus next value. Okay, that is minus 11 by 4. So what is the other value? If I write y minus 3 by 2 whole square is equal to, it is plus or minus x plus how much you got here? 11 by 4. Now finally, what about our answer? So whenever we simplified for beta students, whenever we simplified for beta, what about our value? You just observe here, the vertex is nothing but minus 3 comma 2, sorry vertex not, it is ends of lattice rectum, minus 3 2, minus 3 1, minus 3 comma 2, if I substitute here, x is minus 3, what is the value? It is 12, okay, minus 12 plus 13, that is 1 by 4 plus or minus. Whereas here if I substitute, what is that value? That value you got here, y value, how much here? 2. 4 minus 3, 1 by 4. That means here plus value you have to consider. Okay, plus value, and here also how much you got? Plus value. So in both the cases here you are taking plus value. Okay students, that means finally what about our answers here? Plus here I am taking, and here also plus symbol. Whereas here if I write diagram, if I observe, the diagram is nothing but one is here minus 3 comma 2. Okay, so this is suppose minus 3 comma 2, and now here this value you got, this is minus 3 comma 2, one vertex, sorry one lattice rectum, and the other one is minus 3 comma 1. Therefore we draw diagram in this way. This is here minus 3 comma 2. So this one minus 3 comma 2, it is negative side of x axis, and this is minus 3 comma 1 negative side of x axis. And next value you got here vertex. What is the vertex here? Minus 13 by 4. Okay, minus 13 by 4, 3 by 2. So minus 13 by 4 means what is this value actually? Minus 3 point. Understand? Minus 3 point. That means one parabola, suppose if you take like this, now here you got this is minus 13 by 4 and the other value is here 3 by 2. Okay students, 3 by 2 you got. And next one is here, the next value, it is minus 11 by 4. Minus 11 by 4 means this value is actually minus 2 point. That means this is falling this side. So this is here minus 11 by 4, it is minus 2 point. Okay, and this is here again 3 by 2. So now here this is coming here this side, therefore here I have to take minus sign and here you have to take plus sign. Okay, this is a very important model because it is minus 13 by 4 and here you got how much exactly? Minus 3. Understand? Therefore minus 3 point is this value and here this is actually minus 2 point. Okay, therefore here you are taking plus symbol, whereas this parabola is coming in this way, hence here it is minus symbol. So now in this way we can come across here two parabolas whose here axis is exactly here, it is lattice rectum is parallel to y axis and axis is here parallel to x axis. Understand students? So this is whenever ends of lattice rectum is given, you should be very cautious for giving the values plus or minus. Okay.